What if one small equation was never written, and modern reality never fractured? What if energy was never discovered to be discrete, and the universe refused to reveal its grain? In this alternate timeline, Max Planck never introduces quanta in 1900, and physics walks blindly past the edge of a revolution it does not yet know it needs. From the perspective of a scientist, revolutions rarely arrive because thinkers are bold, they arrive because reality becomes impossible to explain otherwise. Quantum mechanics was not born from imagination but from failure, classical physics collapsing under experimental contradictions. Remove Planck's hypothesis, and the crisis does not disappear, it merely festers, delaying insight while deepening confusion. At the turn of the 20th century, the black body radiation problem remains unresolved. Without Planck's quantization assumption, physicists continue refining classical models, introducing increasingly complex mathematical patches to avoid the ultraviolet catastrophe. These models grow elegant and wrong. Experimental data accumulates, but theory refuses to yield. In 1905, Albert Einstein encounters the photoelectric effect. In our world, he dares to invoke light quanta. In this timeline, without Planck's precedent, Einstein hesitates. He proposes statistical anomalies in electromagnetic waves rather than discrete photons. His explanation partially works, but lacks predictive power. The Nobel Prize is delayed. More importantly, the idea that nature is granular fails to take root. Atomic theory advances slowly. Niels Bohr still proposes his atomic model in 1913, but without quantized energy levels, his model is treated as a useful approximation rather than a fundamental truth. Spectral lines remain mysterious artifacts, catalogued but not explained. Chemistry stagnates at the theoretical level, even as industry advances empirically. By the 1920s, the pressure becomes unbearable. Experiments in atomic scattering, heat capacity, and electron behavior defy classical expectations. Young physicists grow frustrated. Among them is Werner Heisenberg, who, in this world, does not invent matrix mechanics because there is no quantum framework to rebel against. Instead, Heisenberg develops advanced statistical mechanics, focusing on measurement limits caused by experimental interference, not fundamental uncertainty. The breakthrough comes later, and darker. In the late 1930s, driven by nuclear research and geopolitical urgency, physicists confronting atomic instability are forced to accept discreteness, not as a hypothesis, but as an emergency conclusion. Quantization is rediscovered through nuclear decay data, not black body radiation. This version of quantum theory is more instrumental, less philosophical. It explains outcomes, but avoids ontological questions. Erwin Schrödinger still proposes wave equations, but without a clear quantum foundation, his equation is interpreted as a probabilistic tool, not a description of reality. There is no Copenhagen interpretation, because Niels Bohr never gains the authority to frame it. The philosophical debate about observation, reality, and measurement is postponed by decades. The consequences ripple outward. Semiconductors arrive late. Lasers are delayed. Quantum chemistry matures slowly. Nuclear weapons are developed, but with poorer theoretical control, making them more dangerous and less predictable. The digital revolution begins later, as solid-state physics lacks a clean theoretical backbone. Computers emerge as mechanical electronic hybrids rather than silicon-based systems. Most strikingly, the philosophical shock of quantum mechanics never hits early 20th century culture. There is no uncertainty principle to haunt literature, no probabilistic universe to unsettle determinism. Einstein never declares that God does not play dice, because dice are not yet on the table. When quantum mechanics finally consolidates in the mid-20th century, it arrives stripped of wonder. It is a tool of power, not a mirror of reality. Scientists calculate, but do not question. The universe becomes usable, but less mysterious. In this world, humanity still unlocks the atom, but much later, and with less humility. By delaying quantization, physics avoids confusion, but also postpones wisdom. And the final question lingers: was quantum mechanics humanity's greatest scientific leap, or its earliest warning that reality was never meant to be fully controlled? Put your thoughts in comments.
Like, comment, share and subscribe.